Good morning, everybody, and welcome to Math with Mr. W. Today's discussion is about the laws of exponents. Laws. You got it right, laws. That means you can't break them. They have to be what they have to be. And if you don't break the laws, things work out. But if you decide to do something other than what the law says, then you're going to be in trouble. So, the first thing you want to make sure that your students do is they write these down and put it in a folder, and they make sure that they keep them and that you give them problem after problem after problem to go over these thoughts so they can never forget what to do when a situation arises. So let's talk about the laws of exponents. All right. Number one, a to the m times a to the n. So I'm raising the same base to two different exponents. They could be the same exponent. They could be a to the m times a to the m. It doesn't matter. The point is, what am I going to do with those exponents? It's going to be a to the m plus n. I add my exponents. And if your students don't understand, why is that, Mr. Smith? Then you have to give them confidence by showing them why it works that way. So you might have to say, well, I've got a to the fourth times a to the third, and I'm declaring that to be a to the seventh. Well, why am I declaring that to be a to the seventh? Because what is a to the fourth? Well, it's a as a factor 4 times. And what is a to the third? It's a as a factor 3 times. So now I've got a how many times? 7 times. So I've got a to the 7th because I've used a as a factor 7 times. So I just add my exponents, and that'll tell me what I need to know. Okay? That's my first law of exponents. And give them a lot of examples. Don't be afraid to give them tons of examples. You might just throw in examples day after day. I don't know, whenever they're not thinking about it, throw in an example. 5 to the third plus 5 to the 12th. They don't have to figure out what the total answer is, but it's 5 to the 15th. They just have to be able to add the exponents. Okay? So don't let them forget that that's what they're doing. Second law of exponents. All right? What happens if I have a raised to the m divided by a raised to the n? And this is sort of a gimme. If I know that in multiplication I'm adding, what do you suppose I'm doing? That's right, I have to subtract. So think about it this way. Let's say m is bigger than n. M is 5 and n is 2. And this guy lives downstairs, this guy lives upstairs. Say, you coming to my party? Yeah. So get upstairs, come to my party. Okay, I'll come to your party. Now, but what happens was when he moves across the sign, that 2 changes sign. So this becomes a to the m, the opposite of n. A to the m minus n, or plus the opposite of n. We're now adding the opposite of what's down here. We're adding the opposite of whatever n is, because n could be negative to start with. So we're adding the opposite of n. Okay? So that's my second one. So if I have a to the 6th over a to the second, that becomes a to the 6 minus 2, or a to the 4th. And what about the other one? Now, the thing about mathematics is we love having positive exponents. We don't like finishing a problem with negative exponents. That's very important. We want positive exponents. So what if we started with a squared over a to the 6th? Isn't that sort of like we're going to reduce the fraction, aren't we? We're going to reduce the fraction. So this guy's going to come down. So we're going to get 1 over, and this is going to be a to the 6 minus. And it becomes 1 over a to the 4th. Okay? It becomes 1 over a to the 4th. We need to know we have a positive exponent at the end. That's very important. Now our third law of exponents. What happens when m and n are the same? So if I've got a to the m divided by a to the m, well, we know that's 1. Of course it is. And we're going to use this guy to show us that. We get a to the m minus m. What's m minus m? 0. So we get a to the 0 equals 1. So that's our third law of exponents. Anytime we've got a raised to the 0 power, our answer is not 0. It's not 0. It's 1. Because of these two right here, put them together. A to the 0 is 1. It has to be. If it wasn't, then this wouldn't work. Okay? Now, number 4. What if I take a to the m and I raise it to the nth power? What do I do then? Well, just like I've done before, I'm saying that this number, let's say I get an example here, a squared raised to the 3rd. I'm saying a squared used as a factor 3 times. A squared, a squared, a squared. 3 a squareds. Well, what's 3 times 2? It's 6, isn't it? So I just have to multiply these two numbers together, and I'm going to get a to the 6th. So this then becomes a to the m times n. Number 5. If I have a fraction that has an exponent, and I'm raising it to powers, it has powers and it's raising it to a power, then we've got more things to do that. So we're going to do that right now. If I've got a to the m divided by a to the n, and I raise that to the b power, I have to multiply that b times m and that b times n. So I'm going to get a to the bm divided by a to the bn. So I just multiply in just like I did up here. And then I've got one last one to do. And this is probably the one that bothers most kids, but I want you to pay close attention to it. A to the opposite of n. Opposite of n. I say a to the opposite of 3. What does that really mean? And we can go up here and realize what we're talking about, because we moved this guy down to make it become a -2, right? We move this guy up to make it a -2. So think about that. A to the opposite of n is 1 over a to the positive n. And that's the one that kids need to know, but you're not going to see it very often. A to the opposite of n equals 1 over a to the positive n. Now, think about this. If I multiply this across, okay, if I make this a proportion, what's 1 times 1? It's 1, isn't it? Here we have a to the n, a to the opposite of n. And n minus n is 0. So I get a to the 0 equals 1. That's what I need. So we fulfilled all the stuff that we need to do. And we have our laws of exponents that we need to keep on a piece of paper, need to understand. Some will use a lot more than others. I suspect that these two will be the ones that you use more often, as well as number 3. Now, you guys, I know these aren't easy. I know this is not going to be tough for some of your students, but practice, practice, practice to make them aware of what's taking place. Number sense. They have to have strong number sense. I hope you have a great year. I hope you have a great day. And I'll see you next time on Math with Mr. W.